My name is Abelardo Pardo, and I am the Dean of Programs Engineering at the University of South Australia. I'm passionate about engineering mostly because I can see so many things that can have an impact in society. All sorts of engineering projects have the potential to influence a lot of people. During my PhD at the University of Colorado in Boulder, I ended up working 2 summers at AT&T Bell Labs. Back then, one of the best labs studying these things. So I wanted to go a little bit deeper on the study of computer architecture, electronic circuit design, VLSI design. After that, I worked for 3 years for a company, and I realized the importance of these products, how to focus on quality, how to manage to get these customer requirements all satisfied. And it was something that was very enlightening for me. After that, I decided to go into academia because I wanted to make sure that students also had access to this type of technology and this type of knowledge. And I started working first at a university in Boston, and then moved into other institutions, always collaborating with a lot of international partners. And 20 years later, I'm here at the University of South Australia. My role here as Dean of Programs Engineering at the University of South Australia basically requires me to oversee the delivery of the programs, evolve the structure, make sure they are connected to industry requirement, oversee what we call the program teams, which are a team of academics that are each of them responsible of delivering various courses. Also making sure that the labs and the practicals are up to the industry standards. And perhaps another element that is very important for us is maintaining this connection with industry and try to facilitate the students going into internships and work integrated learning experiences. The delivery scheme we have for the Bachelor of Engineering Honours includes some flexible measures to accommodate different requirements from students. For example, we have a common first year that allows the students to study a fixed number of courses and perhaps postpone a little bit the decision about which discipline of engineering to follow. We also have the possibility of online delivery for certain courses. So for those students that want to take the studies part-time or they require additional flexibility, we do have some elements in that program to accommodate these requirements. So the 3 main elements of our Bachelor of Engineering Honours. The first one is all our programs are accredited by Engineers Australia. What this means that every 5 years we have to document very thoroughly the structure of the program, all the courses, practicals, laboratories, infrastructure, and it's reviewed by the accreditation body. And all of our programs have obtained the accreditation. The second aspect that is very important is each of our programs includes what we call a professional practice track. That professional practice basically means that we try to embed in our programs the beginning of that industrial experience that students will achieve when they become professionals. What this means is every year students are not only taking the conventional engineering courses, but they're taking additional courses that are about their professional path, their professional career. We do have programs that include in-curriculum activities, that means activities within the regular courses. We also have additional activities that are organized in collaboration with industry and the potential to explore also internships. All of them are packed up together to make sure that our graduates, when they reach industry, they are fully familiar or very familiar with professional context and how to advance in the professional careers. And the third one is all these activities take place in these world-class facilities here at our Mawson Lake campus, which is perfectly situated in the vicinity of the Technology Park. So as you can imagine, with a degree like Bachelor of Engineering Honours, there is a quite substantial amount of practical activities, labs, and students are pretty much every year constantly engaged in this type of hands-on experience. And we have a very large number of laboratories, around more than 200 of them. And they are divided also into disciplines. So we have civil labs, electrical and electronic laboratories, but also for surveying and for mechanical. Our laboratories and even all the facilities that our courses are utilizing are actually to serve the purpose of connecting with industry and making sure that our graduates, when they reach graduation, they are ready to join the workforce. We received quite a lot of questions about our programs in engineering. Let me answer some of those questions now. So in order to understand a little bit what engineers do when they join the workforce, think of yourself driving a car and using the hands-free set to make a phone call, right? So you're driving in a car, that means mechanical engineers have designed that car, designed that system, measure all the requirements, all the pieces to put together that car that you're driving. Electrical and electronic engineers have designed all the chips that are involved in your mobile phone, all the communications going on, the electronics in the car actually, because cars have more and more electronics. So there you have an example of electrical and electronic engineering. And that car is running on a highway and going through bridges. And that's a discipline of civil engineering and surveying engineering. These are the type of things that when you see them all together, you can see also the impact they have in society. Pretty much everyone is influenced by the work of engineers, circuits, cars, roads. These type of activities are the ones that you will study if you join our Bachelor of Engineering honors. Now, in terms of job prospects, as you can imagine, most companies are somewhat related to these disciplines. There is a lot of interest right now on designing circuits, connecting systems through communication infrastructure. There are a lot of opportunities in the mechanical engineering space as well with the arrival of electronic vehicles. Still a lot of potential in infrastructure building, in civil engineering and surveying. So I think there's never been a better time now to be an engineer. Our students, once they graduate, they usually end up working in lots of engineering companies like Telstra in the telecommunications sector, or BAE in electrical and mechanical engineering. Saab is another one, Lockheed Martin, Hansen Janken, and the job prospects are very good at the moment. The University of South Australia has very strong connections with both the space and the defense industry. We maintain close communication with our industry partners, and what they keep telling us is that they expect what they call well-rounded engineer graduates. These engineers have to be specialized in their discipline, like electrical, mechanical, civil, surveying, the ones we are offering here, but at the same time they have to have a good overview of how different engineering disciplines connect. And this is actually something we have in our program with our common first year. All of our graduates have a very broad introduction to the generic engineering field, and therefore, once they graduate, they are very well prepared to join these sectors like space or defense, which at the end of the day, they require these disciplines, electrical, mechanical, civil, surveying, but with this attitude towards bringing ideas and bringing projects together. So as part of the objective of our Bachelor of Engineering programs to be relevant to industry and to be very connected to industry, we have 450 hours of professional practice. These hours are spread in different elements across the program. Some of them are part of the regular courses, and students work on their presentation skills, team working skills, all the type of skills that industry require our graduates. There is another big portion of those hours that can be based attending events with industry, networking events, sometimes workshops that are delivered by industry collaborators. And we also have the possibility for some of those hours to be part of internships or close collaboration with industry. We're always maintaining the presence of industry colleagues here on campus, typically around projects, around the type of courses that require understanding a broad piece of a problem. And we bring these colleagues to the lectures and to the tutorials to guide the students, provide feedback, and offer them a possibility of getting a bit of a close exposure of what the professional practice is. So as you can imagine, one of the elements that helps a lot when you're studying engineering is your background in mathematics. Mathematics is very important, and there are a lot of modeling techniques and a lot of procedures and a lot of the elements of each one of the disciplines that require a strong background in math. Right now, our requirement for the programs is math methods, but we also have options in case you reach the end of your high school studies and you don't have the right mathematical background, and we can accommodate that through some of our flexible entry programs. So one of the reasons why I think students should come and study our Bachelor of Engineering honors at the University of South Australia is because our program has been carefully designed to accommodate a few key elements for your professional future. One of them is highly practical. The students are continuously doing hands-on exercises connected with the real life. And the other one is a very strong connection with industry. We are very proud of developing very good relationship with industry. Have industry partners continuously on campus guiding our students, and that translates into graduates that are very well received by all the major companies and institutions. So if you have any questions or you want any additional information about engineering, just feel free to let us know, contact us, and I hope to see you on campus.